So throughout this course, you will have heard on several occasions me use the word expected. Expected price, expected interest rates, expected yield, expected inflation. Both I and Mishkin will at different times use this term, and we have something very precise in mind. We are referring to something called expected value. Now, I went over this in class already, but if you didn't get it then or just want a little review, I'm going to make a video. If you feel like you got it, don't feel obligated to watch this. So what is this expected value? Well, suppose you have a security, and it is going to have a payoff that is either $100 or $300. And suppose that it has a 50% chance, which I will write as 0.5, of paying off 100 and a 0.5% chance of paying off 300. Now, if you want to be able to compare this security to other securities, it's going to be really helpful to have a single number that you can represent as the value that you expect to get from this security. So let's see if we can figure out what that would be. We're going to call this the expected value of the security. Now, certainly, if there were a 100% chance of it paying off 100, in that case, you would expect to get $100. There's no trick question here. It's just, well, if you know it's going to pay off $100, then you expect to get $100. And likewise, if there were a 100% chance of it paying off, $300. By the way, I'm going to see if I can do this in one run, so my apologies if it's rough. You would expect to get $300, right? Makes sense. So if there is a half chance of you getting $100 and a half chance of you getting $300, why don't we take a it's like this security is a mixture of these two securities. So why don't we say that the expected amount that you hope to get from this security is a mixture likewise of the expected values of these two securities. In that case, it's going to be, for this top original security, it's going to be half of the expected value of 100 plus half of the expected value of, I did it again, of 300, and that will equal $200. So $200 is now the expected value that you are going to get from this security. Well, that was pretty simple, but let's take another example. Suppose that you were only had a 30% chance of getting the $100 and a 70% chance of getting the $300. In this case, the value that you expect is going to be higher because you've got more of this higher payment. But again, this security, this two-state security, two possibility security, is just a mixture, again, of these two securities. But this time it's weighted more heavily on the second one because there's a 70% chance that you should get it. And since there's more of the $300 security in here, you would expect to get more money out of it this time. So before, we essentially took the average of $100 and $300. Now we need to put more weight on the $300. We're going to have to increase this weight up to 70%, and then we can take this weight on the $100 security and bring that down to 30%. And well, now we have a formula, so we can just plug that in. We could go into our calculator and do 0.3 times 100, that's 30, plus 0.7 times 300, that's 210, which is 240. So now we have a number which represents this entire complex security. What did we do? We took a weighted average of the expected value of the $300 security and the expected value of the $100 security. That's what an expected value is. It is always just a weighted average. What does a weighted average mean? Well, if you're going to take an expected value, whether it's expected yield or expected interest rate or just anything, expected price, expected inflation, you always have a couple of possible different values. It could be $100, it could be $300, it could be 10%, it could be 30%, and you have the probabilities of those values actually happening as well. So what you always do is you just multiply the probabilities times the values, like we did here, probability times the value, probability times the value, and then you add them up. And that's how you get your expected value. It's not a hard concept in some sense. This is something that you guys can totally manage. So let's do another example. Let's talk about expected inflation. Suppose I know that there is a 10% chance that there will be 0% inflation, and there is a 40% chance, a 40% chance of 10% inflation, and a 40% chance of 20% inflation. This is maybe inflation pretty far off if we don't trust our central bank. And a 10% chance of 30% inflation. What do we expect inflation to be? What is the expected value for inflation? Same idea. By the way, if you have the pattern now, I'm not going to do that much new later on. You can stop watching now. If you want some more exercises, keep watching. All right. So what do you think this is going to be? What will the expected value be? Well, again, you just multiply each of the probabilities times the values and then add up. So you get 0.1 times 0% plus 0.4 times 10% plus 0.4 times 20% plus 0.1 times 30%. I have no idea what that equals. Let's see. So that would be a 4%. That'll be 8%, so we're up at 12, and that's 3. I think this is 15%. Pardon me if I made an error in the math. That is how you calculate an expected value. That's all you need to know for this course. I'm going to continue on and do 2 more videos where I will apply this to some of the homework from, I believe, Chapter 8. Hope this helps. If you have any questions, you can leave them in the comments. I'd even answer questions from people not in this class if anyone looks at this. All right. Hope it helped.